Okay, good morning, ladies and gentlemen. This is Professor David J. De Los Reyes. It's been not so long time, maybe 1 day or 2 day. I haven't lectured the long video format because I have taken my exams at the DMB for the so-called vision test and the knowledge test, and luckily I passed it. Okay, for this morning, our topic will be a long video format discussion on what do you call this trigonometry, and we are now on lesson number 42. Okay, let's proceed. The subject matter for this morning will be trigonometry, long video format, lesson number 42, and we are running smooth. We are almost done with trigonometry, but there are still some topics which must be discussed. I think the last two topics will be the so-called sine law and cosine law, the so-called solution of oblique triangles. Okay, let's proceed. The title for the topic tonight will be trigonometry lesson number 42, and the title will be half angle formulas. Half angle. I will be presenting four trigonometric identities that involves half angle. Meaning if the full angle is alpha, for half angle it should be alpha over 2. All our angles will be alpha over 2. That is for half angle. Okay, we will divide any given angle by 2. That's why the topic for tonight will be half angle formulas. What's the application of these half angle formulas? I have taught advanced algebra, advanced mathematics. And in the so-called simplification of AC circuits, I think we needed these so-called half angle formulas. So the application for this are actually for those who will be taking up electrical engineering. In the so-called simplification of current as a function of time for AC circuits under advanced mathematics, we will be needing these formulas. Okay, let's proceed. The first half angle formula is for sine. Of course, sine, the first one, cosine, tangent, and cotangent. If we know if we know the sine and cosine, we could now actually derive the tangent. And if we know the tangent, we could derive for the cotangent. So the foundation on the so-called derivation of this one is by knowing the equivalent of sine of a quantity alpha over 2 and cosine of alpha over 2. If we know these two here, we could derive the tangent, and if we know tangent, we could derive for the cotangent. Okay? This one, you could memorize this one if you would like, but for me, I will just be starting from this one because this half angle formulas actually emanates from this one. This one is easier to remember than this one, right? But this half angle formulas actually emanates from this. Okay, let's try to derive sine of the quantity any angle divided by 2 closed quantity equal to a plus or minus the square root of 1 minus cosine of alpha over 2. The over 2 here is the total denominator, is that it is not divided to the angle here. It's only in the angle on the left hand side, that is sine of alpha over 2. So the value of the radical inside is just 1 minus cosine of alpha, full angle, all over 2. Right? We shall try to derive this one. To derive this one, we will be starting with the equivalent. Actually, there are how many equivalents of a cosine function? I think it's 3. The first equivalent of a cosine of a double angle, okay? Cosine of a double angle, that is, actually we started with the cosine of the quantity a plus b, right? And when a is equal to b equal to alpha, this will become twice alpha. Okay, so this one here emanates from this, but the half angle actually emanates from the double angle. Okay, so we will start with this. Like what I said, this one emanates from this, the expansion of the cosine of the sum of two angles. Okay, the first equivalent of the cosine of 2 alpha is actually 1 minus 2 sine square of alpha. Okay, take note of this, guys. Dividing both sides of the equation, okay, all angles we will divide it by 2. The angle on the left hand side is actually twice alpha. Twice alpha. Right? And the total angle on the right hand side is just alpha. Okay, this is a double angle. This is a full angle. Like what I said, double angle, full angle, dividing the angles for both the left hand side and right hand side by 2. So it will now become cosine. Okay. The total angle on the left hand side is twice alpha. We will divide it by 2. Close quantity equal to 1 minus 2. The angle on the right hand side is just alpha. So if we will try to divide it by 2, it will just be simply alpha over 2. Okay, you got it? The total angle on the left hand side is twice alpha. Like what I said, all angles will be divided by 2, so we will divide this by 2. And the total angle on the right hand side is just alpha. So if we try to divide it by 2, it will become alpha over 2. For the left hand side, this 2 here cancel with this. This 2 here is not a coefficient, it's the equivalent of the angle inside. So actually this 2 here cancel with this. Why it cancels? The operation twice alpha is multiplication, right? So if the operation is multiplication, we are free to cancel. So these 2 here cancel with this. So the left hand side now will be cosine of alpha. Okay, originally it was twice alpha, but after the division of 2, it will now be just simply cosine of alpha. Actually, you can place your quantity here if you want. Yeah. Anyway, it's just a simple angle. Equal to 1 minus 2 sine square. Okay, we divide the angle on the right hand side by 2, so the angle now will be alpha over 2. So if this is alpha, this should be alpha over 2. If this is 2 alpha, this should just be simply alpha. Okay? Or let's try to compute for sine of alpha over 2. It is this one. It's just like we are in algebra. We'll try to solve for this one. So we transpose this one on the left. So it will now be with this one. Equal to 1. We will write this one. Then we transpose this to the right. So this will be 1 minus cosine of alpha. Right? So solving for sine square of alpha without the coefficient 2, we will multiply all terms by, to eliminate 2, we will, it should be the reciprocal of 2, 1/2. Right? 2 sine square of alpha over 2 times 1/2. These 2 here cancel with this. What remains on the left hand side will be sine square of alpha over 2 equal to the right hand side. The total value of the right hand side is 1 minus cosine of alpha times 1/2. This will just be simply over 2. Right? So to solve for sine of alpha without the power 2, what do? Still algebra, we raise both sides of the equation to the 1/2. We take the square root of both sides. We raise both sides to the 1/2. So this is the algebra portion now. Like what I said, if you don't know algebra, you could not simplify things under trigonometry. It's always algebra. The foundation of trigo is also algebra. So sine square of alpha raised to the 1/2, these 2 here cancel with this. What remains on the left hand side will just be simply sine of the quantity alpha over 2. For the right hand side, the square root of 1 minus cosine of alpha over 2, square root. So instead of placing raised to the 1/2, I will just place a square root. And it could either be a plus or minus. Right? Because we do not know the sign of the thing inside. And if the sign of the thing inside is plus, of course, the square root will be a plus or minus. So It could either be a plus or minus if there is a square root over here. So in general now, sine of the quantity alpha over 2 will be plus or minus the square root of 1 minus cosine of alpha over 2. It's this. Okay? This is a half angle. This is a full angle. Full angle. This is a half angle. But the title of the subject matter for tonight, this morning, is half angle. This is half angle. So in general, sine of the quantity alpha over 2 will be plus or minus the square root of 1 minus cosine of the full angle all over 2. Right? So the derivation of this one, actually it emanates from this. For the next one, the next equivalent, if we try to derive this one, we will recall that the other equivalent of cosine of 2 alpha is, in terms of cosine, will be 2 cosine square of alpha minus 1. That was from the previous lesson, right? Double angle. Again, we will divide all angles by 2 for both the left and right. So the left hand side will be cosine of 2 alpha. The total angle on the left hand side is twice alpha. So it will be open bracket 2 alpha over 2. Like what I said, we divide all the angles for both the left and right by 2. Close bracket. Equal to 2 cosine square. The angle on the left hand side is alpha, right? So if we try to divide it by 2, it will become alpha over 2 minus 1. For the left hand side, again, these two here cancel with this. The operation on the numerator is multiplication, so we could cancel 2 and 2 here. Okay, this should be equal to, after the cancellation, the left hand side will be cosine of alpha, and for the right hand side, it will be 2. I will just rewrite this one, cosine square of alpha over 2. We don't touch the exponent, we will just divide the angle by 2. Okay, this is minus 1. And solving for cosine square of alpha, we will maintain cosine square of alpha on the right hand side. Then we change location, so it will now become twice cosine square of alpha equal to this one here. We put it on the left, so it will now be plus, but we rearrange. We put this one here plus 1 on the right hand side, so this will now be 1 plus cosine of alpha. Right? So cosine of alpha and 1 actually is into 1. We just change location. And again, to solve for cosine square of alpha, we will multiply all terms by the reciprocal of 2, which is 1/2. So these two here cancel with this. Left hand side, it will now just be simply cosine square of alpha, I still on camera, equal to. For the right hand side, it will be the sum of 1 plus cosine all over 2. If we try to multiply that by 1/2. And to solve for cosine of alpha without the power 2, we must have to eliminate these two here. We take the square root of both sides, so the other equivalent is we raise both sides to the 1/2. Cosine square of alpha over 2 raised to the 1/2. These two here cancel with this. Laws of exponent, right? Excuse me. So it will now just be simply cosine of alpha over 2. For the right hand side, it will be this total value here raised to the 1/2, or that will be square root of 1 plus cosine of alpha over 2. Okay? Since this is square root, I will just place plus or minus. So the second half angle formula in terms of cosine will be cosine of alpha over 2 will be equal to plus or minus the square root of 1 plus cosine of alpha over 2. It is this. How about tangent? Okay, don't worry with the tangent because we now know the equivalent of sine and cosine. Excuse me. Tangent of alpha over 2 will be sine of alpha over 2 over cosine of alpha over 2. Like what I said, under the study of trigonometry, If this is a half angle, this should be a half angle, and this is a half angle. If this is a full angle, this should be a full angle and full angle. So tangent of alpha over 2 will be sine of the quantity alpha over 2 over cosine of alpha over 2. We now know the equivalent of sine of alpha over 2. It is this. Plus or minus the square root of this. 1 minus cosine alpha over 2 all over plus or minus the square root of 1 plus cosine of alpha over 2. And if we try to simplify this one, again, it's always algebra. We will rewrite the numerator. Okay? But the numerator, we could actually segregate because there is one radical right. This one here can be written as the square root of 1 minus cosine of alpha. Okay? We could remove square root of 2 from the radical on the first one, or it will just be simply square root of 2. So if we try to rewrite this one, it will be plus or minus the square root of 1 minus cosine over 2 over square root 2. And if we try to simplify this one, we will now change the operation from division to multiplication. We take the reciprocal. And also this one can be written as like this. So it will be the reciprocal of this. So it will become square root of 2 all over 1 plus square root of 2. And this is square root of 2 and square root of 2 cancels. Okay? This is under 1 plus and minus. The numerator got a radical sign and the denominator got a radical sign. So the tangent of alpha over 2 now will be plus or minus radical sign, square root. So it will be the square root of 1 minus cosine of alpha over 1 plus cosine of alpha. That is the equivalent of tangent of quantity alpha over 2. Right? We compress the radical side because this is square root. So this one can be written as this one here all over this under one radical side. Okay? And that's actually formula number 3. For the cotangent, there's no problem. We now know tangent. And we know that cotangent is the reciprocal of tangent. So the cotangent of alpha over 2 will be equal to, if this is alpha over 2, this should also be alpha over 2. Okay? It should match. Cotangent of alpha over 2 will be 1 over tangent of alpha over 2. We know tangent of alpha over 2, it is this. Right? So it will become 1 all over plus or minus, this is square root under one radical sign. Okay? And if we try to simplify this one, it's all algebra. Okay? The bottom portion, we can rewrite the bottom portion as the product of the radical 1 minus cosine of alpha. Okay, we rewrite this one under another radical 1 plus cosine of alpha. Okay, we introduce this one and we introduce this one because this one here over this is actually 1. So we could put this one here as square root of 1 plus cosine of alpha. The bottom portion, we multiplied it by 1 plus cosine of alpha, the square root. And actually, this cancel with it. So what remains will be the square root of 1 plus cosine of alpha all over 1 minus cosine of alpha. And if we try to compress it under one radical sign, the cotangent of alpha over 2 now will be plus or minus under one radical sign because this is a square root, this is a square root. So it will just be simply the ratio of this one here over this under one radical sign. So for the cotangent function, cotangent of alpha over 2 will be plus or minus the square root of 1 plus cosine of alpha all over 1 minus cosine of alpha. That's actually half angle formula number 4. Is this. Okay, that's it, guys. If you want to check the validity of these half angle formulas here, just specify an angle here, okay, and then try to compute for the value of this, and it should be equal to the value of the right hand side if we try to substitute the angle. Okay, that's the only way how to check this one. Okay? That's it, guys. These are the four half-angle formulas. Like what I said, I have taught advanced mathematics, and this is needed in the so-called simplification of the so-called current as a function of time. Okay, when we go to circuitry under the so-called study of advanced mathematics. Okay, good morning from Los Angeles. This is Professor David G. De Los. Merry Christmas to everybody.